Hello all. So in the last sessions we have seen about what attention mechanism is all about. We have seen what transformer is, few transformer based language models. We have seen one of the most important transformer based large language model, which was BERT. We have seen sentiment analysis case study using BERT as well, right? So today in this session I would like to discuss about other transformer based pre-trained language models which are available. So BERT is not the only popular written language model which is commonly used in NLP community these days. Initially, yes, BERT was the most popular model, but there are other popular pre-trained large language models which are available other than BERT. So most of these models are already implemented and are publicly available for all of us to use from the Transformers library so that we can integrate them and use them for carrying out various NLP tasks with some changes uh, in the code that can be made. Okay, so one such other pre-trained large language model that is available other than BERT is ELMO. Okay, ELMO stands for Embeddings from Language Models. So this was earlier proposed in 2018 and it is one of the most important libraries which are basically used for contextualized embeddings using unlabeled text. When I talk about contextualized embeddings and unlabeled text, we use this model called ELMO. So ELMO is basically a deep contextualized word in vectors or embeddings, and these word embeddings are helpful in achieving, state of art results in several NLP tasks. So scientists around the globe have been started using ELMO for various tasks, and a lot of research has been happening uh, in this concept of the pre-trained model, which is ELMO. Okay, so its core idea is basically very simple. ELMO is trained on LSTM based language model. Okay, so we are going back again. So ELMO is basically a LSTM trained language model. It uses hidden states as additional features for downstreaming many NLP tasks. Okay, so when I talk about NLP tasks, this particular language model is trained to predict the next token given the previous context using the hidden states, and it can encode the information needed to understand the language. So ELMO does the same with one another. Backward language model and combines these embedding from both directions so that it can encode the information in both directions. This is a small introduction to ELMO. As you can see, as I told you, ELMO is basically a LSTM based architecture. As you can see here in the figure, I have two layers of LSTMs, one in the forward direction and backward direction. So ELMO is designed basically to understand the given sentence in both directions. That is the reason I say this is a deep bidirectional network. Okay, so one of the biggest breakthroughs in this regard came because of ELMO. Okay, so understanding this is very simple because we are not using any encoder decoder architecture here. We are simply using the popular LSTM based architecture for our application. Okay, so ELMO word vectors are basically computed on top of a two-layer bidirectional language. This is two-layered. This is, we call it as BiLM. Okay, so this BiLM model has two layers stacked upon each other. Each layer has two passes again. One is called forward pass and the second one is called as backward pass. Okay, so the architecture you can see here uses the basic LSTM model, and ELMO is basically used to enhance the semantic understanding of sentences. This forward pass, as you can see, contains information about certain words in the context before that particular word, and the backward pass contains the information about the word and the context after it. Okay, so this pair of information from the forward and backward pass forms the intermediate word vectors. Now these intermediate word vectors are fed to the next layer, that is the second layer of this BiLM, and the final representation of ELMO is the weighted sum of the raw vectors of the two intermediate word vectors. Okay, as you can see, the input to the ELMO model is computed from characters. Okay, characters rather than words. You can choose words, mostly it will be characters. It basically captures, even if it is words or characters, it basically captures the inner structure of the word. and then assigns it to the 2-layer word embeddings. Okay, so after pre-training the large language models in both directions, downstream NLP tasks can simply use the Elmo embeddings as features. Okay. Now Elmo basically uses multi-layer LSTM, not just two. I've given you simple example of 2-layer, but it uses multi-layer LSTM, sum of hidden state taken from different layers, weighted in a task specific way. Okay. So the inventors of Elmo showed that adding these features can improve the performance of any model. Okay. So that is a short introduction to what Elmo model is all about. Okay. And the next pre-trained model that I want to discuss other than BERT and Elmo is XLNet. Okay, so XLNet was proposed in 2019 after Elmo was proposed. Okay, so it is important successor of BERT. Followed by BERT, we have this XLNet model. Okay, so this is often referred to as most of the powerful PLM models, pre-trained language models, which is available as of now, because XLNet model basically addresses two issues. Okay, so we have problems with BERT model. One of the problem is train test skew and independence of mask. So those two disadvantages of BERT model are addressed by XLNet model. Hence we say this is an important or most important successor of BERT. Okay, according to the survey, it says XLNet improves upon BERT on 20 different tasks. When we talk about different architectures, XLNet shows much improved performance on 20 different tasks as per the experiments that have been done. Okay, so when you talk about the first issue has to do with how BERT is pre-trained using MLMs, right? We have seen MLM and NSP when we were talking about BERT, right? So we have seen how can mask language model and NSP are used with respect to BERT, right? So during training time, BERT is basically trained so that it can accurately predict masked tokens, whereas during prediction, it uses or it just sees the input sentence which not contain any mask. So this means that there's a discrepancy of information to which BERT is exposed to between doing only masking during training, but testing we're not doing that. So this is the reason why this problem is created with BERT, which is called a test skew problem. Okay. The second issue has to do with how BERT make predictions for masked tokens. If there is no one mask token in the input, BERT makes predictions for them in parallel. Okay, so sometimes because of this also we have discrepancy. Hence we use to overcome the disadvantages of these two points in BERT, we use this XLNet model. Okay, so XLNet can be fine-tuned for machine translation task, translating text from one language to another. Although not specifically designed for translation, its powerful language representation capabilities basically makes it, suitable for many different tasks. Okay, now as you can see this particular example. Okay, so BERT will take statue of liberty. I'm taking a sentence, statue of masking in dash and dash. So the answer actually here is the Statue of Liberty in New York. Okay, so the answer is given at a time in BERT model, whereas in XLNet we pass that through different layers, and each layer will give you output for one masking, and at the end we get masking for other parameters. Okay, so basically XLNet introduces permutation language modeling where all the tokens are predicted but in random order. As you can see, the New and York are not produced simultaneously, but they are predicted in some random to BERT's masked language model, which we are seeing on the left hand side of the figure. Okay, so basically XLNet is also developed by Google Brain in collaboration with some other universities, which is also a transformer based model only, but it outperforms BERT. Okay, so as you can see in the example, you can choose to generate new first, which gives a strong clue for the next word, that is New York or Liberty and so on. Because when I talk about new, there may come the word New York or New Liberty as well. Okay, so the predictions are still made based on all the tokens generated previously. If the model choose to generate Washington first, then the model would proceed to generate DC or Washington DC, or Washington with respect to Lincoln, or many other words. Okay, so XLNet is already implemented in the transformers libraries, so you can directly use it from the library, and you can use XLNet model other than BERT for producing good results for any of the NLP applications. Okay, and the third model that I want to discuss about uh, when we talk about pre-trained language models is ROBETA. Okay, so ROBETA stands for Robustly Optimized BERT. This is another important pre-trained language model that is commonly used in research and industry. Okay, so this is also basically a BERT approach. It is a variant of BERT, okay, which is developed by researchers at Facebook AI. Okay, like BERT, this Roberta also is a transformer-based language model, which also uses self-attention mechanism to process input sequence and generalize and generate contextualized representation of words in a sentence. When I talk about one important key difference between Roberta and BERT is that Roberta was trained on much larger data set using more effective training procedure. In particular, when I talk about this, Roberta was trained on a data set of 160 GB of text, which is 10 times more than the data set that we used for BERT. I'll tell you all these differences at the end of the lecture once I complete all the different versions of BERT. Okay. So additionally, apart from that, Roberta uses a dynamic masking technique. Basically, MLM, masking language model, is one of the important characteristics when we talk about pre-training BERT models, right? So this Roberta uses advanced or dynamic masking technique during training that will help the model to make or learn more robust and give general representation of. So that way we say Roberta has shown to outperform BERT and other state-of-art models in a variety of natural language processing tasks. Okay, so as you can see, Roberta revisits and it modifies many training decisions of BERT. Okay, and it outperforms the BERT model. It makes several improvements over BERT, but the most important is that the amount of training data, 160 GB of training data is taken here. Okay, so overall Roberta is the most powerful and effective language model that has made significant contribution to the field of NLP, which has really helped to drive progress in a wide range of applications. Okay, so the developers of Roberta found out that by removing that NSP, keeping only MLM, it will outperform the performance of downstream tasks. In addition to this, they also revisited the batch size, the way masking is done. I said you right, the dynamic masking of MLM model. Combined, the new pre-trained language model achieved different wonderful results when we talk about tasks like question answering and reading comprehension. Okay, so because Roberta uses identical architecture to BERT and both are implemented in transformer, switching to Roberta from BERT is extremely easy, and if your application already uses BERT. Okay, and the fourth uh, pre-trained language model that I want to discuss in today's session is Distilbert. Okay, so when I say Distilbert, one point that comes into my mind is Distilbert is a small, fast, cheap, and light transformer based model. Okay, so it has 40%, almost 40%, less parameters than basic Google BERT. Okay, but it runs 60% faster because this is used only for few applications for small models. Okay, so this is distill. Basically we use this word distill because this is distill using large batches with the help of gradient accumulation and other dynamic masking techniques without NSP objective here again. Okay, so this is basically not just for pre-training but also can be used for fine-tuning and making some predictions. Okay, for example, the BERT based model we have seen has 110 million parameters and BERT large as 1340 million parameters, right? So we have reduced the size of them and made the smaller version to reduce the computational requirement of modern large language neural networks. Okay, in those cases we use this model which is called as Distilbert. Okay, so this is simply a machine learning technique where given a large pre-trained model, okay, we call it as teacher model, a smaller model called student model is trained to mimic the behavior of the larger model. Okay, so as you can see here in the figure, the BERT model will serve as a teacher. Some distillation over this training data will be done, and a small model called DistilBERT would be generated, and using the softmax function, and above the heads, we put mass delm heads and then derive the output function. So basically understand that DistilBERT is a small, fast, cheap and light transformer model which is trained. Okay, so where is that actually used? We use it for NER, biomedical entity recognition, paraphrasing, some question answer, etc. For very small applications, we use DistilBERT. Okay, so it has its versatility in applications from chatbots to many different tasks. Okay, so here as you can see, the student model is trained with MLM. Uh, we calculate loss as well as a cross entropy loss between the teacher and the student. This will push the student model produce a probability distribution or predicted token so that it will improve the performance. Okay, so as you can see, 40% smaller but 60% faster, while retaining 75% of the performance task has been observed when it comes to DistilBERT. Okay, and the next version of BERT that I want to discuss, which is pre-trained model, is Albert. Okay, so and this addresses the computational complexity problem of BERT. Okay, that is the reason we call Albert is basically a light BERT. Okay, Albert models have similar parameter size, smaller parameter sizes when compared to the previous BERT models. For example, the BERT base, for instance, has 9 times as many parameters as the Albert base, and the BERT large has 18 times as many parameters as the Albert large has. Okay, so Albert Large achieves comparable performance compared to BERT Large, almost 1.5 times faster than BERT. Okay, so instead of resorting to knowledge distillation as we have seen in the distill, Albert makes a few changes to its model and the training procedure also. And one design change Albert makes to its model is how it handles word embeddings. Okay, so in most of the deep learning models, word embeddings are usually represented by and stored in a lookup table that contains word embedding vectors and all that stuff, right? So this is a lighter version of BERT. Okay, so as you can see, all the three words called dog, chocolate and cat are given to BERT directly, but here we pass them through a linear layer. We understand embeddings in a different way and then pass them to the BERT. Okay, so this is a light version of BERT. Okay, so which is called as Albert. Basically it addresses issues by decomposing word embeddings into different stages. Okay, so when I talk about two important stages, the first stage is similar to how word embeddings are retrieved from a mapping table. Okay, and the next stage, these short vectors are expanded using linear layer, as you can see here in the picture, so that they match the desired input dimensionality without reducing the accuracy part. Okay, so as I told you, these are the four important versions of BERT, Roberta, DistilBERT. As you can see, we have compared different parameters. Okay, as you can see, DistilBERT has the smaller number of parameters, that is only 66. And when I talk about pre-training data, as you can see, everything is on 16 GB. Only Roberta is trained on huge data, that is 160 GB. Okay, so my BERT is based on MLM and NSP. Roberta is based only on MLM without NSP, with dynamic masking done on NLM. DistilBERT is distillation on the original BERT model, and Albert is the smallest version with reduced parameters, which will also not use NSP. Okay, so these are some important different parameters comparing the four different other pre-trained language models which are based on BERT. Thank you so much.